Hello and welcome to our video lecture presentation on the sum and difference of two cubes. Here are our templates right here. So whatever problem that we have to format it first so that it fits in the a to the third plus b to the third format, or if there's a minus, it has to fit in the a to the third minus b to the third format. Let's take a look at our first example here. We cannot use these templates yet because we're halfway there to this problem meeting one of these two templates. Because there's a plus, we would be looking at the top template here. Because the problem is this 8 right now. This first term is perfect. It has an x to the third, which is what we need. We need to have an exponent of 3. However, right now this problem has this 8 having an assumed exponent of 1. So this does not meet the template. So what we have to do is we have to convert or repackage our problem so that our 8 is reflective somehow of having an exponent of 3. So what you say is, what raised to the third power will give me 8? And that's 2. Why? Because 2 times 2 times 2 is equal to 8. And that's what exponents do. It says how many times you have to carbon copy your base by. So an exponent of 3, we have to carbon copy our base 3 times and multiply them all together. So now this right here repackaged, both the problems are the same here. This is repackaged though where it's in the proper format. So what is my A? My A is X. And what's my B? Whatever the base is that's raised to the third power. My B is equal to 2. So now all we simply do is just substitute from here on out. We look at our top template because we started off with a plus. Our top template shows a plus, and we just substitute x for A, 2 for B. So A plus B is the same as saying x plus 2 in this example. A squared, put in x for A. Minus a times b, x times 2 is equal to 2x, because the commutative law of multiplication says that order doesn't matter between the x and the 2, so I'm showing the number first. Plus b squared, so I put in 2 in for b, 2 squared is 4. And believe it or not, you could check this answer, because if you do the dissection distributive method, if you dissect the first set of terms in the first set of parentheses and individually multiply them to the second set of parentheses, you're going to get one big long strand of terms that are everything is going to cancel out, all except an x to the third plus 8. So you can actually check your answer to make sure it's correct. So that is how we go about solving the sum and difference of two cubes. The hardest part is trying to repackage the problem so it matches this template. One of these two, depending on if we have a plus sign or a minus sign. So let's look at the next problem here. I have x to the third plus 27y to the ninth. So our A term is fine. That's no issue. Our A is x. However, this needs reworking. So we're going to, we have to get it a base so that when raised to the third power, we get right back to 27y to the ninth. Let's first handle the number. What raised to the third power will give me 27? 3, because 3 times 3 times 3 is 27. So now, what raised to the third power will give me y to the ninth? Y to the third. So as a check to make sure we did this properly, whenever you have an outside exponent of 3, it gets distributed by multiplication to all the exponents or assumed exponents within the parentheses that exponent is tied to. So we have 3 to the third, which is 27, y to the 3 times 3, which is y to the ninth. We did that properly. So my A is x, my b is 3y to the third. So now we're going to use the top template again and plug everything in. We're going to substitute in x for a. Okay, so everywhere I saw an a, I put in an x. Now for b, wherever I see b, I'm going to replace it with 3y to the third. Now let's clean this up a little bit. All right, so 3y to the third times x is 3xy to the third. You just want to put the letters in alphabetical order. That's the nice way to show it. Now here's a little trick. Make sure when you have an outside exponent like this that it gets distributed to everything that has an exponent or an assumed exponent. Just don't distribute the 2 to the y to the third. It's 3 to the second, which is 9, and y to the third raised to the second power is y to the sixth. And that is how we solve a problem like this. So at this moment right now, I recommend you pause this, try to solve this to see if you understand it, and then if you can, hit the play button and see if what we go over and what we write as our answer matches yours. Okay, let's see how you did. So, couple different methods of factoring here. Notice that there's something common between 4x to the sixth and 4. Remember that this 4 is assumed to be multiplied by 1. So you say what's common? That'd be a 4. So what am I left with? X to the sixth minus 1. So now we have to get this into the a to the cubed, b to the cubed format. So what raised to the third power will give me x to the sixth, x to the second. And 1 could be raised to any exponent because 1 to the third is the same as saying 1 times 1 times 1. So we are right now in the proper format. So my a is x squared, my b is 1. So now we have to use, let's see here, so now we have to use our second template here. So now I'm going to substitute in, so we had a 4. So now I'm going to replace x squared wherever I see a. Now I'm going to replace 1 wherever I see b. So now let's clean this up a little bit. I have 4 times the quantity x squared minus 1. X to the second raised to the second power is x to the fourth plus x squared plus 1. We're not exactly done because this x squared minus 1 is a difference of 2 squares. I have 2 terms with a minus sign in between them, an even exponent, and I could take the square root of the 1 evenly. So now I could break the x squared minus 1 into x minus 1, x plus 1. And then that's multiplied by x to the fourth plus x squared plus 1. So that's how we would solve a problem like that. Hopefully you were able to get at least the majority of it. So let us look at this problem now. So everything had, now it may look at first glance as though this is in the a to the third, b to the third format, and it is not. because this 8 has an assumed exponent of 1, this 27 has an assumed exponent of 1. So let's focus on the 8. What raised to the third power will give me 8? That's 2. And what raised to the third power will give me x to the third? X to the first. For here, what raised to the third power will give me 27? That'd be a 3. And what raised to the third power will give me 8 to the third? 8 to the first, or just a. So now we have this in the right format that we need. So a is 2x, b is 3a, and now we just use our second template. So wherever I see a, I'm putting in 2x. And wherever I see b, I'm putting in 3a. So now to clean this problem up a little bit, it's 2x minus 3a times, remember the 2 has to get distributed to everything that has an exponent or an assumed exponent. So there's an assumed exponent of 1 on the 2 and an exponent of 1 on the x. You distribute that by multiplication with this outside exponent here. So you get 2 squared, which is 4, and then, 4x squared plus 6. 2 times 3 is 6. Ax, I just switched the order because the commutative law of multiplication says order doesn't matter in multiplication. Plus, and then we have 3a all raised to the second power. If you want, you could expand out 3a to the second power as 3a to the first times 3a to the first. So showing it this way, 3 times 3 is 9. 8 times a is a squared. Or you could have just distributed the 2 by multiplication to the assumed exponents on the 3 and the 8. And this right here is how you would solve problems related to the sum and difference of two cubes. Thank you for listening. Bye-bye.